Plastic particles collect viruses on their surfaces through chemical bonds, electrostatic forces, and hydrophobic interactions. This makes the viruses more resistant to external factors like ultraviolet radiation, temperature, or chemicals, thereby prolonging their infectiousness. Professor Richard Quilliam, lead researcher at the University of Stirling, said, "We found that viruses can attach to microplastics, which allows them to survive in the water for 3 days, possibly longer. Being infectious in the environment for 3 days, that's long enough to get from the wastewater treatment works to the public beach," said Quilliam. In other words, viruses attached to nanoplastics can remain infectious longer than they would in a free-floating state. Nanoplastics can transport viruses over great distances through air, water, and living organisms. We weren't sure how well viruses could survive by hitchhiking on plastic in the environment, but they do survive, and they do remain infectious. Microplastics can influence how viruses interact with host cells by altering the conditions of their environment. For example, nanoplastics may weaken the protective mechanisms of cells, potentially making it easier for viruses to multiply. Moreover, microplastics can create conditions for interactions between viruses and bacteria, facilitating the exchange of genetic material. This could increase bacterial resistance to antibiotics. Such processes may contribute to the spread of pathogens and increase the risk of emerging infectious threats.